we will compute the time complexity for the insertion sort algorithm, and for that please do watch video on insertion sort. If once this example is clear, it will be easier to understand the time complexity considering the different scenarios. The first scenario is the best case scenario where input is provided in the sorted order. Moving with the first iteration, we try to insert this 15 element into the sorted array of single element, that is 5. On comparing this 15 with 5, we find that 5 is less than 15, so 15 must be appended at one position, and it involves the one comparison. Moving with the second iteration, we try to insert this 25 element into the sorted array. Here we have sorted array with 2 elements in ascending order. So this 25 is compared with the last element from this sorted array, which is 15. As 25 is greater than 15, it is getting placed at the 2 position. This also involves a single comparison of 15 and 25. 25 is not getting compared with 5 since it finds that it is greater than the last element from the sorted array. So obviously the elements which are preceding to this 15 are smaller than this 25. So with this assumption, no any further comparison is carried out. Simply this 25 is placed at the 2 position. In next iteration, we try to insert this 35 element into the sorted array. Rightly we have the sorted array with 3 elements, 5, 15, 25. On comparing this 35 with the last element from the sorted array, we find 25 is less than 35. So obviously 35 should be appended at 3 position. It is not going to compare with the elements which appear before 25, with the assumption that as all these elements are in ascending order, these elements are smaller than 35. And this iteration also involves a single comparison. With n given number of elements, n minus 1 iterations are enough to sort these elements. With n minus 1 iterations, n minus 1 elements get sorted. So obviously nth element is at its right position. And rightly we have seen with best case scenario, every iteration involves one comparison only. So if n numbers are given, then with n minus 1 iterations, only n minus 1 comparisons are carried out to get the sorted order of elements. If input grows, then the number of comparisons also grow linearly. So that's how the best case time complexity of the insertion sort algorithm is omega n. If 10 elements are there, then 9 iterations are going to be performed, and in every iteration 9 comparisons are going to be carried out. If 20 elements are given, then 19 iterations are going to be performed, and in every iteration one comparison is involved. Total number of comparisons which are involved in sorting these 20 elements will be 19. So that's how linearly this complexity grow, and that's how the best case time complexity of the insertion sort algorithm is omega n. Average case and worst case time complexity of insertion sort algorithm is theta n square and big O n square respectively. Since the number of comparisons which are involved in sorting the elements or inserting the element into the sorted array involves nearly n square number of comparisons. Coming to the space complexity, see here the second iteration where we are trying to insert this 5 element into the sorted array of 2 elements. Here we find that 5 is less than 35. Rightly 5 is at 2 location. When we find that 5 is less than 35, this 35 should be moved. So it gets moved to the 2 location. So this position gets rewritten. And in order to have the track of the element which is to be inserted into the sorted array, it must be stored somewhere. And for that purpose we use the additional space. And space complexity is always considering the additional spaces than the spaces which are taken by the input. So this is the constant number of space which is taken by insertion sort algorithm to have the track of the element which is to be inserted into the sorted array. And this space is not going to increase as input grows, as it is involving the constant number of additional spaces. The space complexity which occurs in insertion sort is 1 in best case, average case, and worst case. So this is the best case, this is the worst case, and this is the average case respective space complexity of insertion sort algorithm.